Namaste, teachers. I'm just going to walk along with you the 3D. What are the things are there? What is important in the examination point of view? And what are the extra questions I have come across? And the mistakes generally student makes in 3D. So these are the things I'm just planning to focus. So in between, you can stop me and you can raise your hand, you can stop me, you can ask me and clear the doubts. We'll discuss the doubts together. Even the teachers, you can add, you want to add any points at the time, you can please join. Anyone can please join at that time. That is, we'll discuss. It is not only the learning for, actually, I found last year when I took this class for 10th and 9th, we learn a lot along with you, and many points were shared among the associate teachers. We also learned and we adapt with our children. This is the exchange program only I call this particular session, which was very useful. So I just wanted everyone to participate. That is the reason yesterday I just gave some shared points and all. I just put it in the group. So first, let us recall what is basically we are talking about it. So 3 mutually perpendicular lines we are having, which act as axis, and right-handed system we are taking, which is dividing the space into 8 octants, and basically through that we are starting our 3D in class 11th. So x-axis, y-axis, z-axis, point on the x-axis, x comma 0, 0. Point on the y-axis 0, y 0, point on the z-axis 0, 0, z. So this is a basic thing. Origin 0, 0, 0 we talk. And what are the coordinate sign and all we talk. And then what is the distance of the point from the axis, we talk all those things. X coordinate, y coordinate, z coordinate basically form the point in the 3 dimension. So, and then when we take the 2 points, the distance between the 2 points, we have learned it. In 2 dimension, we take root of x1 minus x to the whole square plus y1 minus y to the whole square. In 3 dimension, we are having the 3rd dimension z axis also plus z1 minus z to the whole square, just added in the formula. Distance from the origin, since the point is 0, 0, 0, we get root of x square plus y square plus z square. We call that modulus of the position vector, we call here this one. And then distance from the point is PA perpendicular, PB perpendicular, PC perpendicular, distance from the axis. That is what basic thing. And this is one of the most important thing, which is we studied in vector also, we studied in, we are studying in 3D also, internal division and external division. Mx2 plus M1x2 plus M2x1 by M1 plus M2, M1y2 plus M2y1 plus M1 plus M2, M1 Z2 plus M2 Z1 plus by M1 plus M2. So external division, numerator and denominator, we have a negative sign, and midpoint is similar to our 2 dimension where we have Z1 plus Z2 by 2. So this is the question, we get it based on this. One of the coordinate will be given, that is x coordinate of the point will be given. The other ratio, you have to find it and find out the other points. We are having questions in 3D also based on this, where we will be using. When the question is find the ratio, the M1 and M2 will be replaced with k:1 ratio, and then we can proceed. That is what this particular slide. And the most important part of our 3-dimensional geometry, we are entering here. Alpha is the angle made by the position vector or the directed line with respect to x-axis. Beta is the angle made by the y-axis and the line, and gamma is the angle, positive direction angle only it is, with respect to the z-axis and the line. So alpha, beta, gamma are the angle, but if you take with the cosine, that will become cos alpha, cos beta, cos gamma. In general mathematics, we write that as with the letter L, M, N. So L is a L comma M comma N are direction cosines we call, or cos alpha, cos beta, cos gamma we say. Now the most important questions comes the next one. When we are talking L square plus M square plus N square is equal to 1. Here we are going to have 2 questions which comes in the examination. So let us talk about that question first. So before that, let us recall direction cosine of the x-axis 1, 0, 0. Direction cosine of y-axis 0, 1, 0. Direction cosine of z-axis 0, 0, 1. This is very important. Why this concept is very important? The reason is, while I'm talking here, one slideshow. While I'm talking here, this point is very important. Later, while we are writing either the plane equation or the line equation, when we are telling parallel to x-axis, or the concept parallel to y-axis, or the concept parallel to z-axis is coming, at that time, we need the direction ratio. So, or direction cosine, both are same in this case. 1, 0, 0 direction cosine with respect to x-axis, 0, 1, 0 with respect to y-axis, 0, 0, 1 with respect to z-axis. This is important. So based on this, we have L square plus M square plus N square equal to 1. So we are having cos square alpha plus cos square beta plus cos square gamma is equal to 1. So based on this, we are having two questions. One is find the value of sin square alpha plus sin square beta plus sin square gamma. So that value, find it. This will be followed with the identity sin square theta plus cos square theta is equal to 1. So sin square alpha can be written as 1 minus cos square alpha plus sin square beta can be written as 1 minus cos square beta. Sin square gamma can be written as 1 minus cos square gamma. That is.
Answer is 2, madam.
Yes, sir. Answer is 2. Superb, sir. Here it is cos square alpha plus cos square beta plus cos square gamma is equal to 1. So answer is 2. This is one question which is not there in the reader. It comes. Another question is followed with the same concept. Find out cos 2 alpha plus cos 2 beta plus cos 2 gamma. Anyone would like to say the procedure? I will write it. Cos 2 alpha, cos 2 beta, cos 2 gamma. We go for again the trigonometric formula. We use it. So I just give some nickname for many formulas so that my children remember. So this formula, I give the name star formula. There is no relation between star and this formula because this will be useful in many places. You come to inverse trigonometry, you start limits and derivative, you use it. Trigonometry, we use it. And then you go for inverse trigonometry, we use it. And then you go for derivatives, it comes. Then it comes in the integration. In all the places, this formula comes. So I just give the name so that when I say tell the star formula, they remember it. That's it. 1 plus cos 2 alpha, 1 minus cos 2 alpha. These two formula, I say it is star formula. So 1 plus cos 2 alpha is 2 cos square alpha. And 1 minus cos 2 alpha is 2 sin square alpha. Here also I gave subtraction sign and sign letter comes. All the nicknames, and I give only the below average and average, will talk about it and take something. So I just do all these things. So cos 2 alpha is nothing but we can write it as from here 2 cos square alpha minus 1. Other directly the formula we can recall. So 2 cos square beta minus 1 plus 2 cos square gamma minus 1. So substituting here a 2 cos square gamma minus 1. So that gives you the answer. 2 into cos square alpha plus cos square beta plus cos square gamma is 1. 2 into 1 minus 3, answer is minus 1. So these are the two sums which comes in the examination using this particular concept cos square alpha plus cos square beta plus cos square gamma is equal to 1. So this is what is the part. And then the next one. Next I am going for once again to make the strength and the direction ratio or point in the x-axis or point in the y-axis. First I make a unit cube. Unit cube and teaching this helps us. Even we are having in the miscellaneous, we are having diagonals of a cube. One sum is coming. So diagonal of a cuboid room, what is it? 4 by 3, the answer comes. So for that also this will be helpful. So making it direction ratio also, we are recalling point on the x-axis. Again, the direction ratio 0, 1, 0, 0, 0, 1. So this makes them to remember the diagrammatic representation, will make them to remember it concept correctly. And point in the xy plane 1, 1, 0, point in the is xz plane 1, 0, 1. Point in the other plane is, it is not given here. That is 1, 0, 1, 1, 1, 0. 1, 1, 0, xy plane here it is there. And here it is xz plane and yz plane. YZ plane is the other side, that gives you the value as YZ plane is here. That is YZ plane 0, 1, 1. So recalling this concept will help you if you draw and show this particular thing. So while in our teaching, we can incorporate this particular thing. So while we are giving the question itself, find the direction ratio of AB, find the direction ratio of AC, find the direction ratio of BC. Like that we can give many wording so they understand that part also. Direction, cosine, direction ratio, find the direction ratio of the diagonal, all the possible diagonal. With a simple number when we give, how to pick up the diagonal, that is the XY plane and the point is that they have to pick it. That will become a point in the XY plane and point on the Z axis. Another diagonal is point on the X axis and point on the YZ plane. This makes one diagonal. And then point on the Y axis and point in the XZ plane. We'll make another diagonal, 3 diagonal over. What is the 4th diagonal? Origin and the point in the space. That makes the 4th diagonal. So the identification of the diagonal in the cuboid will be thorough. This we can say it in the classroom observation also. In the classroom, we can make the student to stand in the position and then find out what are the points and then find out the diagonal between the 2 people. We can say, and that way also we can find it. So on the space, we can say one person is there, and then that way we can just connect the points and we can say what other things are there. So this is one of the activity we can do it in the classroom, so that the concept of direction ratio and the cube and the direction ratio of the x-axis, direction cosine of the x-axis, all those things will be thorough for the children. So this is another thing I'll like to share. So this is a concept to tell that a square plus b square plus c square is not equal to 1, whereas L square plus m square plus n square is equal to 1. To tell that a, b, c are the direction ratio, whereas L, m, n are the direction cosine. The connection between this is a by magnitude, b by magnitude, c by magnitude of this will give you L, m, n. Plus or minus we put it because it is a straight line. So the line direction ratio can go here or this side. So a plus or minus symbol is needed. So in a one more question, when it comes find the direction ratio for the center paper, we can say that put this sign and write the direction cosine or direction ratio. But when it is a sum, when we are doing at that time, no need for plus or minus, because equal to 0 equation is going to come. So it is not going to make much difference. Now the direction ratio and direction cosine with respect to 2 points. So x2 minus x1, y2 minus y1, z2 minus z1. Very important all these things to go about it, because later I'm going to, I'll be talking to the students on their own to frame the equation. So at that time, when I talk about all these points only, children remember it. So giving the direction cosine of the line, joining the 2 points is important. Here we can connect it with the vector AB vector is equal to OB vector minus OA vector. Or when I take it as BA vector, OA vector minus OB vector. Since the line is going, you can subtract from here or here, or to here, or this point to this point, or anyway they can do it. This concept thoroughness we can give it so that they are ready for next. Now I'm coming to the definition of a straight line. These are the basic things we do it. In these basic things, one of the other questions is points are collinear we are having. That concept is going through direction ratio of AB we find it, direction ratio of BC we find it. After finding direction ratio of AB and BC, we prove they are proportional, A1 by A2, B1 by B2 equal to C1 by C2. The direction ratios are proportional. And very important concept in this is AB, dr of AB and dr of BC are proportional. After that, compulsory to write the point B is a common point. So when we are talking about this part, as B is a common point, they are lying in the straight line. We are proving for collinear points. So not only direction A ratio AB, direction ratio BC, we have to find it. And after finding, we have to show they are proportional. After telling they are proportional, since B is a common point between AB and BC, they are collinear. That conclusion language is important when we are doing with respect to the points and using 3D concept. Coming to the next one, this is the unsymmetrical form of a straight line. That is, when 2 planes are there and the 2 planes intersect, intersection of 2 planes always form a straight line. intersection of 2 points is a straight line. So ax1 plus by1 plus cz1 plus d1 equal to 0. a2x plus b2y plus c2z plus d equal to 0. This is the unsymmetrical form, but we are not talking about all these things. But the introduction of straight line while we give, we can show the example of the textbook and we can introduce them. Two lines always meet at a point. By folding a paper, we can say. And coming to the our concept, what is there in the thing. So always whenever we are teaching, every time recall the concept that parallel and perpendicularity. Everywhere we are doing that only. A1 by A2 equal to B1 by B2 equal to C1 by C2. That only. While you are talking here, I given to you a point with the position vector A and a director vector is given. So how to connect with this? So we take a point, arbitrary point R vector. So this is A vector. So R vector minus A vector is equal to lambda times B vector. And then compulsory when we are writing this particular part, we are having R vector equal to A vector plus lambda B vector. So proper parallel concept is AB vector is equal to lambda times CD vector. So using that only we are doing. While we are writing as a number, subtraction x minus x1 is equal to x minus x1 by A equal to y minus y1 by B equal to z minus z by C equal to R. So general point when we take equal to R, I take. So what is x is equal to, what is y equal to, what is z equal to, most important concept. So we are doing it. The next thing is giving the children all these things will help them to go for 4-mark question or any other higher level question. This concept will help them. So basic understanding, basic concept, line through the origin when I'm writing in terms of x, y equal to mx and z equal to nx. Suppose if I'm writing in terms of y, x is equal to my, z is equal to ny. In terms of z when I write, x is equal to mz and y equal to nz will come. Equation of the x-axis, in a 2-dimension y equal to 0, in a 3-dimension y0 z0. Equation of y-axis, x0 and z0. Equation of z-axis, x0 and y0. And parallel to x-axis while I am talking, this part after introducing the pattern, once again I'll come back to this slide and we will talk about this. Now the next concept is 1-point form. This is what is the 1-point form and 2-point form. Then it is 1 point is there, already I have discussed 1 point x1, y1, z1 is given and the arbitrary point is x, y, z and the direction ratio is given to you A, B, C, so that you have it as a ratio. Direction ratio is subtraction x minus x1, y minus y1, z minus z1 is the direction ratio of the line here. Here the direction ratio LMN in terms of direction cosine given. So x minus x1 by L, y minus y1 by M, z minus z by N. If it is a direction ratio, x minus x1 by A equal to y minus y1 by B equal to z minus z by C equal to R. So here this is the line. When 2 points are given, we just take the direction ratio instead of A, B, C. We just subtract these 2 points only. X2, Y2, Z2. So the direction ratio become X2 minus X1, Y2 minus Y1, Z2 minus Z1. You get it. So this is what is the direction ratio of the line. So when these 2 points direction ratio is X minus X1, Y minus Y1, Z minus Z1. These 2 point direction ratio is X2 minus X1, Y2 minus Y1, Z2 minus Z1. So when you take it as a ratio, again, go with the A1 by A2 concept, B1 by B2 concept, C1 by C2 concept. All these things work will be there. Why I am talking all those things in depth? So my way of teaching is, I give them all these things. Then I ask them to frame the equation. We are having in a class 40 children. I am very particular, all the 40 children frame the equation. Give one equation. Maybe your 10 to 15 minutes will go in the class. That is fine, I feel, because the children, if they don't know to differentiate between the straight line and the plane, which was my experience in the beginning of the year when I started teaching. So they don't identify what is the line, they don't identify what is the direction ratio, they don't know to take it up, what is the A vector, what is the B vector. When I write it as R vector is equal to A vector plus lambda B vector, this is a point on the line, this is the director vector. That differentiation they are not having. And most of the children doesn't have the habit of, when they say the equation, they start from I plus J plus K plus lambda times, they say 2I plus 3J. So it is a R vector, the general point also they don't say. So to train all these things, I do all these things. So when I give you 2 points on their own, I ask them to take the 2 points and then they take and then they frame the equation. When they say, I write it on the board, they will be telling and they will be writing. So minimum 10 students will write all these things. So 10 children will understand this part and the remaining children, how will I go about it? I divided the concept of standard form of the equation, standard form of the straight line. After explaining what is the standard form, coefficient of x, coefficient of y, coefficient of z should be 1. If it is not there, it is not in a standard form. Training them, I don't full 3D chapter, I don't touch the reader at all, because everything is, we can frame the equation, we can frame our own equation, except the foot of perpendicular. Even that also we can frame our equation, but the point lambda will come in constant. It will not come in a constant, it comes in fraction. We make the sum complicated. Only for the foot of perpendicular, I make it a point that I take the reference book and take the question. Remaining all the concept, I take the question from the children and then with that only I go. I plan it in such a way, concept wise I just go. How I have made the slide, in the same way I'll be proceeding. So first I will be asking them to frame the equation, convert. So once the standard form is there, then I train them with this particular pattern. So all this full pattern on 10 children, I have told this side to this side, this side to this side, all this is over. Then I go for the pattern where I don't have the direction ratio. Direction ratio don't have no, direction ratio is 0. So y equal to 2. Y equal to 2 means in the standard form, x minus 1 by 2, y minus 2 by 0, z by 4. Then children ask me, Mom, we don't write the 0 in the denominator. So here you are writing, yes, I just tell them, when the direction ratio comes, I have with respect to I component, with respect to j component, with respect to k component, I'll be having, but I cannot write it. That is the reason I'm presenting this. So this thought process should be given. So all the possible way, this is the second, first pattern. This standard pattern is over. This is the first way, non-stand pattern. You have a question and where the children are identifying the direction ratio. With respect to y, some students can give. With respect to z, some students can give. Some student can give x is equal to 0 and y minus 3 by 4 and semicolon I equal to lambda and y is equal to 3. So this way also they can give the equations. So training them with the equations of x with the direction ratio 0, training will be given for that. The next pattern I'll be going for is where the coefficient of x is not positive sign, minus x, minus y, like that. So change the sign, multiply and divide by this thing, by the negative number, you get it. So this is the next pattern I'll be training them so that they understand this pattern. So when we are thorough with our concept, how many different way we can write it. So while teaching itself, we can introduce all the possible things. So children are very comfortable. So this is simply multiplying with minus sign. Another pattern I introduce is 2x is equal to 3y equal to 4z. I tell them 2 ways. One is directly writing here 1 by 1 by 1 and then divide the numerator and denominator by 2 and then you get it as taking the 2 common x by 1. You can bring the 2 down, that is x by 1 by 2. That way is one method. Another method I say it as from the beginning itself you can talk about the LCM of the coefficient of x, coefficient of y, coefficient of z. That is here when you take it as 12 will come. So you can divide everything by 12. So directly direction ratio comes. So this method put them, because all these question comes in the 4-mark question or 5-mark question or 6-mark question. In the plane equation, they don't give it in the standard form. So at that time when we teach only one sum. So while we are teaching this beginning of introduction itself, we introduce all these things, children will be comfortable. So the next pattern coming here is I'm having 5x equal to I think I have few questions bent down. I'll just try to pick it up. The design is okay. I'll make it by myself, no problem. Here 5x equal to 2, 5x minus 3 equal to 2y minus 3 equal to 3z by 2. So you can, children can divide by 1 and then take the 5 outside, bring the 5 down, or divide the first one by 5, everything by 5, 5x minus 3, 5x by 5 minus 3 by 5 by 1 by 5, and then 2y minus 3 by 2 by 2 by 1 by 2, then 3z plus 2 by 3 by 3 by 1 by 3. And then they can take the LCM of this number, and then the fraction they can remove, or if they can keep it in the way. So very important to make it in the standard pattern. This is what. The one more standard pattern when we come across in the equation is, you'll be having 2x plus y is 2x plus y is equal to 3, comma, y plus 4z is equal to 7. Like this, you'll be having it. So how to make it as a, how to get the direction ratio, how to bring it in the standard form. So you write it as y is equal to 3 minus 2x, and here is y is equal to 7 minus 4z. Then you bring it 3 minus 2x is equal to y is equal to 7 minus 4z. Now they can divide by minus 2 to make it as a standard form, both numerator and denominator for everything, or change it and write it as minus 2x minus 3 by minus 1, and y by 1, 4z minus 7 by minus 1. First remove the minus sign, then divide the numerator and denominator by 4 to make it standard form, divide here by 2 to make it standard form, divide by 4. This is what is important, so the children can identify. So all these questions we need to train them the beginning itself. So what I was telling is, after teaching them what is the line in the standard form, we go back to all the possible pattern. So the possible pattern we should register in our mind clearly, so that we don't miss any of the concept here. And this is what is important till here. The next is usual patterns only, not a complicated. Finding the angle between the lines. So cos theta is b1 dot b2 by magnitude b1 and b2. Here children will never go wrong, because we are training the children here itself. This is the b vector, this is the b vector, this is the b1 vector, this is the b2 vector. In all the possible way, we are training them what is a b1. When 40 children are framing 40 equation, every children are thorough with what is b1 and what is b2. There is no possibility that children take a wrong b1 and b2 value in this area. So that way when we do it, b1 dot b2, I'm not going with this, I'm not spending time in this. Everyone means, of course, all of us know everything. I'm just sharing my experience. At the end, I wanted you also to share your views and your way of teaching. Now, what I have written two equation. I'm just question is find the angle between the two lines. The two lines while we are giving, we have to give in such a way. As I told you, we are only framing the equation. We are not taking the equation from the book. So when we frame the equation, one you frame in the vector form, one you frame in the Cartesian form, so that children knows to pick up the B correctly. Sometimes not to give in this way. You can give it in the combination form. Linear combination form you can give it, so that they segregate, they identify the B separately. And here also not to give it in the standard form, the other form. So B1 and B2 in the reader we are having direct question. So whereas we are training them with the formula also, we are training them in the standard form also. So like this when we do it, the children will learn it definitely better, because all these things I'm not giving the training when I do this sum. I have given already the training of the children how to make it standard form. So standard form they make it, and then they proceed with the formula. So this is what theta equal to cos inverse writing. Most of the children forget it, so that we have to train it. B1 dot B2 vector by magnitude B1 and magnitude B2. So we are writing this. So that is what is the next angle between the lines. Now the next is perpendicular concept and parallel concept. Two lines are parallel if the direction ratios are proportional. So B1 parallel to B2. So B1 vector is equal to lambda times B2 vector. And here perpendicular concept B1 dot B2 is equal to 0. One hard question which I have come across, which I have come in the sample paper also. Prove that the lines, two lines are given. Actually, if you are not training them, this is a straight line, they don't know, because the textbook we are just having the equation in the form x minus x1 by a equal to y minus y1 by b. equal to Z minus Z1 by C. Like that only is there. If you are not training them, they don't even understand this is a straight line. So two lines are given. One is this line, another is this line. These two lines are given. Show them they are perpendicular to each perpendicular, provided this condition is satisfied. So let us write it in the standard form. Standard form is x is equal to, here common letter is y. So we equate y is equal to py is equal to x minus q. Y is equal to x minus q by p. And here ry is equal to s, z minus s, y equal to z minus s by r. And making as equation, x minus q by p equal to y equal to z minus s by r. So the direction ratios are p comma 1 comma r. Direction ratio. Again, the other equation also we do it in the same way. X minus q dash is equal to p dash y. So x minus q dash by p dash is equal to y. And the next equation is z minus s dash is equal to r dash y. So z minus s dash by r dash is equal to y. So equating x minus q dash by p dash equal to y equal to z minus s dash by r dash. Now direction ratio p dash 1 and r dash. So now perpendicular concept a1 a2 plus b1 b2 plus c1 c2 is 0. This is a1 and a2 and a3. Why I'm telling we should not be very lazy while I'm writing. Children will understand we can't go for it. A1, B1 and C1. And even the below average children will write it in the same way in the notebook. And they will never go wrong in this concept, small things. So this arrow mark and writing, this is A1, this is B1, this is C1, this is A2, this is B2, this is C2. When we are taking here P dash, sorry, I'll go here. P dash plus 1 into 1 plus r dash is equal to 0, which is what we want to prove. We proved it. So I just wanted to make the importance of non-standard form to bringing the standard form we are introducing while we are teaching. So that is the thing. Nothing, we are not supposed to bring all these things after we finish the reader portion. So we in 3D chapter, we should never go with the reader procedure. We have to take care of ourselves in such a way, we introduce everything to the children in a comfortable way. The next concept is skew lines. While we are going for skew lines, very important to talk about what are coplanar lines. Lines in the same plane, either parallel lines or they are intersecting lines. So skew lines, we can show the example from the classroom, or we can show two children to catch two notebooks and make a pen and moving of that make the students to move in the direction they never meet. So non-coplanar, non-intersecting lines are skew lines. Give them the concept clearly. After giving them the concept, distance between the lines, wordings only we have to say. Distance between the lines. Because in the question, find the distance between the lines only will be there. They will not ask, find the distance between the skew lines. The language skew will not be there. So we have to make them to understand distance between the lines comes as soon as they see the question, they should write it in the first step, write it in the standard form. That is what we have to instruct. Any time in the question, they are reading the sum immediately, whether the line is in the standard form observation. After the observation, identify the A1, A2, B1, B2. So while, if you are, now you can recall what I said to you. I said to you, all the possible pattern to write it, I said to you, both the form, all the standard form, how to change. Now, if you have given them very good training in this area, then they come to this particular question, while we are telling the formula, at that time they will be very comfortable. So now, distance between the skew lines. When I'm talking, this is the distance between the parallel lines and this is the distance between the skew lines. So it is nothing the projection of A2 minus A1 on B1 cross B2. A2 may be anywhere, A1 may be anywhere. But we can draw a line and parallel, we can take it as a vector. We can bring the A2 and A1 here And then we can take A2 and A1, A2 minus A1 projection, we can take it on B1 cross B2. B1 cross B2. B1 cross B2 projection. Projection, we know that we have studied in the vector chapter itself. Projection of A vector on B vector is projection on A vector on B vector. Projection of A vector on B vector is A vector dot B cap. That is which is nothing but A vector dot B vector by magnitude B vector. So now while we are telling here, we write it as distance is equal to A2 minus A1 dot B1 cross B2, B2 by magnitude B1 cross B2. Make the children to draw the diagram. So it is a distance, a vector perpendicular to vector is a cross product. We have given the instruction very clearly. So perpendicular vector we are taking so that this is coming, the projection we are able to do it. Important, dot product may come plus or minus. So this symbol is modulus. Use the word modulus. Modulus of A2 minus A1 dot B1 cross B2 by magnitude B1 cross B2. Why the word magnitude here? Vector is not a number. It is not a scalar. It is a vector. So we cannot write, distance cannot be a vector. Distance is a number. So here we use magnitude. Here we use modulus. The purpose of modulus is the dot product negative has to become positive. Magnitude is anyhow positive. Denominator is positive. Now coming here, the distance between the parallel lines. Distance between the parallel lines, this is what we are talking. This is, of course, this is not there. Distance between the parallel lines, this distance we are taking. So while we are talking about the distance, here the formula is D is equal to A2 minus A1 dot B vector by, cross B vector by magnitude B vector. So this is what the cross product comes here. So while we are writing, write the formula simultaneously and speak. This is the magnitude. Here the symbol is magnitude and here the symbol is modulus. While they say the formula, magnitude A2 minus A1 dot cross B vector by magnitude B vector, and here it is A2 minus A1 dot B1 cross B2 by magnitude B1 plus B2. This is what important here. While we are writing here, that is, this is A2 parallel lines while I'm talking, A2 minus A1 cross B vector, that is a vector perpendicular to both the vector, that is a B vector is this one, parallel vector, whatever is here, B vector, here also it can be, and cross product, vector perpendicular to both the vector is a cross product, that comes the distance, and here the angle is sine theta. Sine theta I'll show in the next diagram. Sine theta is equal to opposite side by what do you call the hypotenuse side. Sine theta is equal to D into hypotenuse side, that is nothing but P2 A2 minus A1. Here they use P2 minus P1, whereas we use in the formula this thing, and then this particular thing B when we are taking, and then cross product when we do it automatically A2 minus A1 cross B vector, and here also cross B vector. And this is a cross product while we are doing, this cross product, and I'll just go with the other way. That will be more comfortable. So you can go for replace that A2 minus A1 cross B vector. So substitute here, automatically you get it as magnitude B, opposite that distance it comes down. So you get the distance is equal to A2 minus A1 cross B vector magnitude by magnitude B. That will be sine theta. So these two formula differentiation we give. Most of the children here they write dot. So this mistake happens in many times. So you have to be very careful. It is a cross product. One of my students says that, ma'am, cross product will come in the distance somewhere, ma'am. So here two B1 and B2 are different. Definitely in the B only it comes. So before B like that, they have some shortcut to remember it. So we train them with the magnitude. We train them with the modulus. So next concept. Show that the lines are skew lines. Show that the lines are coplanar lines. Show that the lines are skew lines. If the distance is not equal to 0, they are skew lines. If the distance is equal to 0, they are coplanar lines. So this concept you have to give. So that is A2 minus A1 dot B1 cross B2. If that value is not 0, modulus that value is not 0, of course denominator B1 plus B2 will come, is not 0, they are skew lines. And if they are distance is equal to 0, they are coplanar lines. Once again, I have given you the concept of making into standard form and then proceeding. That way the questions are given. So first changing to thing and then use the formula and getting. Of course, we know all these things. So just to give you the idea, the question may be asked, show that the lines are skew lines and show that the lines are coplanar lines. So this concept we can take care. And the next question is, here they are not telling that show coplanar. So we can show the lines are intersecting. So if this question is not given, show the lines are intersecting lines. We can show they are coplanar. That means we can show that A2 minus A1 dot B1 cross B2 is 0, we can show. And then we can say that they are coplanar lines. Coplanar lines, they intersect, so the intersecting lines. But the question they are asking, show that they are intersecting, also find the intersection point. So compulsory, we have to proceed with the uniform procedure. All of us knows it. So let us just recall once. Equal to y plus, the most important question comes in the examination. I just say this question comes in this year also, so that our children are comfortable to get some mark. So z minus 6 by 5. We're taking this is equal to lambda, this is equal to mu, framing 3 equations here and framing 3 equations here, solving 2 equations, getting lambda and getting mu, substitute in the third equation. And then if LHS is equal to RHS, they are intersecting lines. And substitute lambda in the general point, x is equal to, we are going to write 3 lambda minus 1, y equal to 3 lambda minus 1, z is equal to 7 lambda minus 5. Substitute the lambda value, we get the point of intersection. So this is the next question we come across all these things. Show that the lines are coplanar, find the point of intersection. So both are same language only. Show that the lines are coplanar, find the point of intersection, they can follow the same procedure. So they should not stick into their mind that coplanar means shortest distance is 0. Skew lines, definitely shortest distance is not 0. Okay? And here that is the way we need to talk about it. Another important concept we come across in this, find the equation of a line passing through a single point and perpendicular to 2 lines. So find the equation of the line passing through a point, minus 1, 3, minus 2. So immediately we write it as A vector equal to, R vector equal to A vector plus lambda B vector. So minus I plus 3j minus 2k plus lambda times B vector. Now this particular line is perpendicular to one line. So we have it as L is perpendicular to L1. So L perpendicular to L1. When lines are perpendicular, never at the line L1 and L1 dot L is equal to 0. Only vectors dot product is 0. Here 2 vectors we are having. One is A1 vector, another is B1 vector. A1 is a position vector. So it is the formula we have cos theta equal to B1 dot B2. Here B perpendicular to B1. So of course B dot B1 is 0. And second, again, to understand I am drawing separately. Otherwise, we can show it in a 2 dimension. Showing directly will be difficult. So L perpendicular to L2 is B perpendicular to B2. So B dot B2 is equal to 0. And I come across children writing like this: A plus 2B plus 3C equal to 0. And here minus 3A plus 2B plus 5C equal to 0. Then using the 10th standard cross multiplication method, A by, B by, and C by, I come across. But I never suggest this method. The reason is my children 99% go wrong in the sign concept. Whereas training them with the determinant will give them a comfortable. Talking to them very often, the parallel concept and perpendicular concept and vector perpendicular to vector is a cross product. So here a vector, B vector, perpendicular to two vectors B1 and B2, Therefore, B vector is equal to K times B1 cross B2. Telling them this part very often. So easily they can find B1 cross B2 using the determinant I, J, K writing and 1, 2, 3 and minus 3, 2, 5. Determinant expansion gives them the answer. They can come back and substitute. So my way of training is only using the determinant part, not with the cross multiplication part, where I find it most of the children are comfortable to get better marks, not to make mistake in this part. They know the concept. Making mistake in the calculation part is very less. So that is what is this particular thing. Similar concept is the next one, whereas equation of the line passing through one point and parallel to two planes. So line is passing through the point 3, 0, 1 and parallel to two planes. So that means normal is perpendicular to B vector. Again, the normal is perpendicular to and again B vector. So B vector perpendicular to N1 and B vector perpendicular to N2. So we get it as B vector equal to K times N1 cross N2. So they are able to comfortably, they can proceed with this thing. Similarly, writing line R vector is equal to A vector plus lambda B vector. B vector, they are able to find it 3i plus j, 0j plus k plus lambda time B vector. B vector comes from here and I, j, k writing, they will be able to get it. Fine. Another question which we come across in the new pattern question, it is not there in the reader. So when we are talking about this particular part, show that the lines are intersecting lines, not there in the reader. And of course, only we are having shortest distance and what do you call angle between the lines. Only these two concepts are there. Whereas we come across, show the lines are coplanar, show the lines are intersecting lines, find the point of intersections, and find the, this is there in the miscellaneous, find the equation of the line passing through the point and perpendicular to two lines, passing through the point and parallel to two planes. These two are there in the miscellaneous. Let me come across one particular question, which is not there in the reader, but it is a sample on some book. We means generally we see in the question when we want to give the hard question, we give this. Find the equation of the two lines through the origin. Both the lines are passing through the origin, which intersect the line. The one line is given at an angle pi by 3. So let me draw the diagram. The two lines are passing through the origin. These two lines equation only, L1 and L2, I have to get it. This line intersecting a line, that is here the line, x minus 3 by 2, y minus 3 by 1, is that right? Yes, sir? At an angle pi by 3. This is what the question. Find the equation of the line L1 and line L2, which is intersecting the line L at the at an angle pi by 3. Find out the equation of both the lines. Our step 1 will be, we write the direction ratio of L1. General point of L1 will write it. General point of the line L. Equation of line L is x minus 3 by 2 x minus 3 by 2 is equal to y minus 3 by 1 is equal to z by 1. So general point is x is equal to lambda, 2 lambda plus 3, y is equal to lambda plus 3, and z is equal to lambda. General point, we found it. After we find the general point, even the point M also in the same way, you have 2 lambda plus 3 and lambda plus 3 and lambda. Similarly, point N also same thing, general point it is. So 2 lambda plus 3, lambda plus 3 and lambda. Now, I'm going to find out the direction ratio of PM, drs of PM. I get the direction ratio of PM by subtracting this point M and point P. Point P happen to be 0, 0. Subtraction becomes 2 lambda plus 3 minus 0, lambda plus 3 minus 0, lambda minus 0. Same thing will come. Similarly, direction ratio of Pn, I find it. Direction ratio of Pn. No need only one enough, but still I am for learning, I am telling. That is here 2 lambda plus 3, again lambda plus 3, and lambda comes. So I take this as B2 vector, and I take here the dr of the line as B1 vector. Direction ratio B1 vector is 2, 1, 1. So if you are observing, here I have a line L1, and here I have a line L, and the angle between them is pi by 3. So here I have a B vector, and here I have a B1 vector. So I can go for angle between the line concept. So cos theta is equal to B1 dot B2 by magnitude B1 and magnitude B2. Here angle is pi by 3. Cos pi by 3 is equal to B1 is, I can have it as 2i B1, let me recall, 2i plus j plus k dot B2, we got it by direction ratio of PM, 2 lambda plus 3, lambda plus k and lambda, 2 lambda plus 3 I plus lambda plus 3j plus lambda k by magnitude. If I take 2 square plus 1 square plus 1 square, and here it is 2 lambda plus 3 the whole square plus lambda plus 3 the whole square plus lambda square. Cos pi by 3 is 1 by 2 is equal dot product. If I do it, 4 lambda plus 6, and here lambda plus 3 plus lambda by root 6, and here root of 4 lambda square plus 9 plus 12 lambda plus lambda square plus 6 lambda plus 9 plus lambda square comes. So simplification, half is equal to 6 lambda plus 3 plus 6 is 9. 6 plus 3 is 9 by root 6 into root of 6 lambda square plus 18 lambda plus 18. We can take it as half into taking here 3 you can take 2 lambda plus 3 by here root 6 into root 6 will become 6, and here root of lambda square plus 3 lambda plus 3. So in this 6, root 6 into root 6 is 6, that will become 2. This 2 and 2 cancel, and this 3 also cancel. Cross multiply, square lambda, you can get 2 value. Substitute lambda in the 2 places, you get the equation of the line. Using 2 points you can find it. So let me repeat. I think further you can work it out. So this is the way finding the lambda. Cos theta is equal to, once you get the lambda, you are able to find out the point M and point N. So point M is there, point P is there, and 2 point form you can find the equation of PM. And lambda will have 2 values. Here being a quadratic equation, 2 answers will come, 2 lines equation. One line will be PM, another line will be PN. You can go for it. So this is another question. And the last one we are going to discuss about is distance. So here while we are talking about it, find the coordinates of foot of perpendicular, length of perpendicular drawn from the point to the line, and also find the image of the line. When the 6 more question used to be there, this is an important question, and this is find a foot of perpendicular. Coming here is while we are talking, compulsory to ask the children to draw a line. Draw a line. I prefer this in the Cartesian form so that easy to write the general point. So it is x plus 1 by 2 equal to y minus 3 by 3 equal to z minus 1 by minus 1. And then I take the point P as 5, 4, 2. Then I'm very particular to making them to draw 90-degree board and give the name M. So my first step is I ask them to write step 1, write the general point of the line. I give them the step number so that they don't miss out any steps. whether 6 steps or 7 steps are there, they identify general point of the line, general point of the baseline L. So taking into lambda, get x is equal to 2 lambda minus 1, y equal to 3 lambda plus 3, z is equal to minus lambda plus 1. So this is what is the general point. After writing general point, I'm very particular, I insist, I make it mandatory to write it here, 2 lambda minus 1, 3 lambda plus 3, minus lambda plus 1. To make them understand, general point, all the points, the m also is there. So m point, we take it in terms of lambda, I write it. My second step is writing the direction ratio of PM. That comes by subtraction, 2 lambda minus 1 minus 5, 2 lambda minus 1 minus 5, 3 lambda plus 3 minus 4, minus lambda plus 1 minus 2. That makes it as 2 lambda minus 6, 3 lambda minus 1, minus lambda minus 1. After writing this, my third step is direction ratio of line L. That is compulsory to check whether it is in the standard form. So 2, 3 minus 1. So that is what writing. Then observation. Fourth step is L perpendicular to PM. So it is a line and the line cannot be perpendicular. So the direction ratio B1 perpendicular to B2. So dot product of the both the steps, second step and the third step, dot product is 0. B1 dot B2 is 0. Writing and then 2 into 2 lambda, 2 into 2 lambda minus 6 plus 3 into 3 lambda minus 1 minus 1 into minus lambda minus 1 is 0. That makes it as getting the lambda. After getting the lambda, now only this mandatory part helps. So put up perpendicular is M, putting the lambda in M, not in direction ratio PM. Most of the cases we come across, children put lambda here and they go wrong. So the diagram will make them very clear. My lambda is put up perpendicular, I have to get it, put it in the point M and get it. So X, Y, Z, they get it. Once they get it, distance, they can find it, and images using the midpoint, they can find it. So these are the concept we come across totally in 3D line concept. So today I'll just start with the plane. Few concepts we will talk about it, and tomorrow we will talk about more concept. And that 15 minutes I'll just share few things. Yes, Govindarajan sir, can you go ahead? Yes, sir. Govindarajan sir, can I go with the...
Yes, ma'am. Yes, sorry, I was mute. Yes, ma'am.
No problem, sir. Yeah. So now this is how the unsymmetrical form and symmetrical form we were talking. Like that, a geometrical locus in a plane is such that any 2 points on the locus and every point on the locus is also there in that line. That is, a geometrical locus is a plane if it is such that P and Q are any 2 points on the locus, then every point on the line PQ is also a point in the locus. That means we are having infinite lines we can frame, and infinite forms it comes. All the lines together, we combining together, we get a plane. This is a general definition of plane, but we are having the specific case we are having, where we are having first degree AX plus BY plus CZ plus D equal to 0. A square plus B square. This is what this comes from. A plane can be given when the normal to the plane is given and the distance from the origin is given. We can write the plane equation. That is what our learning. First learning is R vector dot n cap is equal to D naught. I write it as D naught. Whenever cap comes, I make it a point to write D naught so that the children are very clear. This is a unit vector. At that time, this is the distance from the origin. I don't write R vector is dot n cap is equal to D as it is given in the reader. I just make it a point to write it as n cap is equal to D naught. Whenever unit vector you convert it, when the normal vector you convert it into unit vector, that time this will become the distance from the origin. So I give the training here in such a way, the diagram, all this introduction, how we do it, the same way we give, the plane will be there. And the plane, we take it as the normal vector distance. all those things. We'll talk about all those things, how the derivation comes. That explanation is over. Then we give a general plane equation, normal vector x plus y plus 2z is equal to 5. A general plane equation convert into dot product gives you r vector is xi plus yj plus zk. This most of the children doesn't know. While we convert into Cartesian form to vector form, when we say, I give you the equation r vector plus 5i plus 3j plus k is equal to 7 if I give, they don't know to make it as a convert into a Cartesian form in the beginning. How much ever we give the introduction, then we have to train them r vector is xi plus yj plus zk, normal. And then dot product formula is what? Formula of dot product is two formula. One is cos theta is equal to b1 dot b2 by magnitude b1 dot b2 equal to magnitude b1 magnitude b2 cos theta. The other formula is a1 a2 b plus b1 b2 plus c1 c2. Here we go for a1 a2 plus b1 b equal to 7. a1 a2 plus b1 b2 plus c1 c2 is equal to 7. We go for it. This concept we have to tell them. Then only they write it as x into 5 5x, 3 into y 3y, and z into 1 z is equal to 7. Like this they learn it after giving them many training. So this is important to tell them what is a normal form and vector form. Give them the training in such a way, how in the standard form of a line we were giving, like they give them the training r vector 3i plus 3j minus k equal to 7 after giving, converting into Cartesian form to Cartesian form, 3x plus 3y minus z is equal to 7 or minus 7 equal to 0. This is of the form capital AX plus capital BY plus capital CZ plus capital D equal to 0. Tell them this is what. And here r vector dot n vector is equal to D. This is the n vector is equal to D, sorry, not n cap, n vector. N vector is equal to D. And then we convert into r vector dot n cap is equal to D naught. For that, what to do? Train them. So in this form, what to do? In this form, what to do? Train them. So you get it as here it is r vector dot 3i plus 3j minus 3k minus k divided by root of 3 square plus 3 square plus 1 square is equal to 7 by root of 3 square plus 3 square plus 1 square. Now r vector dot, there is 9 plus 9, 18 plus 1, 19. 3i by root 19 plus 3j by root 19 minus k by root 19 is equal to 7 by root 19. Now we have converted into the form r vector dot n cap is equal to 7 by root 19. Now after writing, we have to ask them the question. First question, what is the direction ratio? Which is nothing but direction ratio of the normal. Normal, the diagram, we have to make them to write it so that they register the vector perpendicular to the plane is a normal. So direction ratio of the normal is 3, 3, minus 1. Second question, direction cosine of the normal vector is 3 by root 19 and 3 by root 19 minus 1 by root 19. And the third question is n cap. N vector is unit vector. They ask in language, so we should teach them. The most difficult part children find it in three-dimensional geometry is the English language and max form. English language represent what they don't understand. So we need to train them for that, continuously asking this question. So unit vector of normal. This is English and it max is n cap. So that gives you 3i by root 19 and 3j by plus 3j by root 19 minus k by root 19. This is a unit vector. And the fourth question, the first question, second question, third question. And the fourth question is the distance from the origin is 7 by root 19. Suppose here it is negative. So there itself we have to make it as positive. Suppose here it is minus sign is given. Immediately we should train them r vector dot minus 3i minus 3j plus k is equal to 7. training them here itself, D is positive. So automatically here, this will become, this and all will become negative, negative plus, and this will become positive. So that training should be given. D naught is distant from the origin. So that is the next question. And the fifth question we have to train here is foot of the perpendicular from origin. Perpendicular from origin. So that gives you L D naught, M D naught, comma N D naught. So here we are having L, M and N direction cosine, and here we are having D naught. So L D naught, M D naught, N D naught. So what I wanted to convey is, while we are teaching, as I was telling, we are not, especially plane, we should not go with the reader. That line, at least you can go with the leader, only point of intersection, extra question you can insert, but the plane don't go in the order, children get confused. But once, my experience is, once you finish all the plane concept, spend 2 periods to talk to them, each and every sum of the reader, they themselves will answer the question. They are very comfortable with the 3D. So that is what is my observation. After finishing all the concept, we go back to the reader, children understand. We would have covered every sum in the reader by doing this pattern. So children also will be comfortable. We also will get the satisfaction of doing it. But compulsory to make them familiar with the reader question. That is important. So as I told you, the language and interpretation of the mathematics, they do it when we discuss the reader question. So what I wanted to convey is here, when I give the question x minus y plus 2z is equal to 10. So when it is given, your first part is converted into vector form. R vector dot I minus j plus 2k is equal to 10. My second question is direction ratio of normal. Third question is direction ratio of normal unit vector. That is the direction cosine of normal. And fourth question is n cap. And fifth question is foot of perpendicular from origin. From origin. So these 5 questions gets over in this pattern. So which is very important. And that is what we do it in the plane introduction. After the introduction of plane, I just go for a general concept which children should know. Equation of YZ plane. Equation of YZ plane is x is equal to 0. Here, YZ plane, while I'm talking, it is a YZ plane. Perpendicular will be, that is perpendicular to x-axis. So direction ratio of normal of YZ plane is the x-axis direction ratio 1, 0, 0. This concept we have to introduce. This we can show the board is the YZ plane, and the x-axis we can show the line where we walk. From the board we walk perpendicular. So that way we can show where our footstep is going on. That footstep is a perpendicular. We walk along the x-axis we can show. Similarly, from the wall is the XZ plane, my right side wall where I am writing to the board. From this the XZ plane. I walk from there towards the door of the room. When I walk, that is the XZ plane is there. And I walk, normal will be 0, 0, 1, 0, 0, 1, 0 by axis. And then when we talk about XZ plane normal is XZ plane normal is 0, 1, 0, and YZ plane normal is 1, 0, 0. Like that, all the things we can talk about it. XZ, XY plane. XY plane is normal is 0, 0, 1. So this concept introduction we have to give. What is a normal to which plane? Equation also we have to say is XZ plane equation is Y0, XY plane is Z0, and the normal will be 0, 0, 1, and normal will be 0, 1, 0. Here normal is 1, 0, 0. That is what we have to tell. And I was telling previously to discuss about the equation. I could go back and discuss. And here equation of the plane parallel to the axis, parallel to the x-axis. It won't intersect the x-axis, so y and z will be there. Ax will not be there because that is 0 into x will be there. By plus bz plus d. Similarly, parallel to z-axis, parallel to y-axis. This concept introduction we can give to the children. And now, even though this part is there, a into x minus x1, b into y minus y1, c into z minus z1 equal to 0 passing through the point, I find Actually, I learned it only this year, I have to say. Every student is a teacher to us, I will say. The student, when they represent in a better way, when we observe it and we give it to the children, it reaches them in a better way, I feel it. So I'll be sharing this, what I learned it in this method, even though I have a passing through the point and normal is given to you, passing through the point 1, 2, 3, and normal vector is given 1, 1, 1. So what the children have made is, in a 4-mark question or simple string, they first found the normal. With the normal, they write the equation ax plus by plus cz plus d equal to 0. Using the normal, they write 1x plus 1y plus 1z plus 1d equal to 0. Then they substitute the point here. X, Y, Z point 1 plus 2 plus 3 plus d equal to 0. D value is founded as minus 6. So equation of the plane is x plus y plus z minus 6 is equal to 0. They never use this particular pattern. So here in this pattern, what happened when big numbers are coming, opening the bracket, the sign mistake happens. Whereas here, there is no chance of making that mistake. So that is one of the things I learned it this year. And intercept form is x by x intercept plus y by y intercept plus z by z intercept is equal to 1. This is the intercept form of the plane equation. And the same thing, normal form is when we use Lx plus my plus nz is equal to d naught, actually it is. At that time, it is a normal plane equation, normal form of plane equation. Otherwise, it is a general equation, ax plus by plus cz plus d equal to 0. This is a ABC, or the direction ratio of the normal, which we discussed earlier. So now, I'm going to pattern plane equation. I made it all the pattern like this to discuss with you. I'll just go one by one. All the 7 patterns are there. We'll discuss all the 7 patterns. After that, as passing through the line of intersection, we are having 6 patterns. All the 6 patterns we will learn it. And then line passing through the plane and the line. That is a point of intersection of the line and the plane concept. We'll learn it. These are the basic things I have decided to discuss tomorrow.